All right, so we got cosine of 2 theta times sine of 7 theta. So I'm looking for cosine times sine. So look in your formulas, and you'll see one that says cosine of u, sine of v, and it's equal to 1/2 with a bracket sine of u plus v minus sine of u minus v. So let's see, it's cosine of u, so this is my u, 2 theta is going to be u, sine of v, so 7 theta is going to be my v. So let's plug it into our formula. So 1/2 bracket sine of u plus v, so 2 theta plus 7 theta, minus sine of u minus v, so 2 theta minus 7 theta. All right, so 1/2 sine of help me there, what is that? 9 theta minus sine of, it's a plus. Okay, yeah, the formula has a minus in it. Sine of -5 theta, right? Okay, now some of y'all came to me on one of the tangent problems and we looked at it. We don't like our angles to be negative in there. So remember, sine is odd. So because it's an odd function, we're able to take and change the sign of the inside if we change the sign of the outside. Remember that? Has to do with the fact that it tells us that negative sine of theta is equal to sine of negative theta. Okay? So if I want to change the sign on the inside to make it a positive, I have to change the sign on the outside. And so that's what I did there.
Why is it a positive?
What's that?
Why is it a positive?
What's positive? Say it again.
I was wondering why it was positive instead of a negative.
Oh, because we divided it. We did get a -5 theta, but we don't like our angle to be negative in there. So we use the fact that sine is an odd function, which I'm going to write it again. So it means that negative sine of theta is the same as sine of negative theta. So if I want to change the sign inside there, that means it's going to become positive, which means it's going to change the sign on the outside of it. So that's why I changed the sign of both of those. So we end up with 1/2 times sine of 9 theta plus sine of 5 theta.